Hi, so we're starting off the year talking about radians and degrees, the similarities and the differences between them. When we talk about angles, we want to have a standardized way that we draw them, so it helps us understand each other when we say certain things and can communicate across problems. So the first thing, when we draw an angle, we lock it down to the XY plane. The initial side is the positive x-axis, and that's just, we think of it as the beginning of our angle. Likewise, the second branch of our angle, we call the terminal side. Think about that like final, terminal is final, where the angle ends. And that could be in any of the four quadrants. So here's an example of a terminal side. And when we give a positive number, so if we say draw an angle that is 60 degrees, we open that terminal side from the initial side in a counterclockwise direction. And if someone told you to draw a degree that's negative 20 degrees, totally possible, but we would take that and we would go the clockwise direction to indicate a negative angle. Okay, notice right here, this arrow is pointing to our terminal side. All right, so just some practice here. To draw each angle in center position, we're going to start by just drawing just a rough XY plane here to have our four quadrants. Alright, and then again, you're always going to have your same initial side. So for all three examples, I'm just going to go ahead and start the problem by sketching that initial side. Okay, and now I'm going to look at the actual example and think a little bit more about how to do that. So notice 150 degrees for the first one. My best advice here is to think about what we know really well, which is that a right angle is 90 degrees. So the way the x and the y axis meet each other, they form perpendicular angles. So each quadrant would be 90 degrees. So if this is 0, because that's where we're starting, if I drew the terminal side on the initial side, there would be technically no angle, or an angle with 0 degrees. So if I open the terminal side up along the y-axis, now we're at 90 degrees. And then again, if we went straight across all along the x-axis here, that would be 180 because we have two quadrants of 90 degrees. So 150 should go somewhere between 180 and 90. So it's 30 degrees short of 180. So maybe somewhere right here, I'll draw my little arrow and then I'll get rid of this right angle I made. And then I'm showing, okay, I opened up this direction 150 degrees. All right, 810, same idea. All right, if you'll remember, one full circle is 360 degrees. So obviously 810 is larger than one full circle. So something I might do to help myself is say, okay, if I open up all the way around, that would be 360 degrees. All right, we need to keep going. If I were to go another full circle, 360 plus 360, that's going to be 720 degrees. So that's two full circles, and we still need to go a little bit more. How much more? We need to find the difference between 810 degrees and 720 degrees. Okay. All right, notice that is 90 degrees more. So from that, where we would have ended right back on the x-axis here after two full rotations, we need to go 90 degrees more, which would put us right here along that y-axis. So our 810 degree angle actually would look like a 90 degree angle. And then negative 70, so you see the negative, we're going to open the opposite direction. So we're going to open clockwise. So if we were to go down all the way to here, we'd be moving negative 90. So we don't want to go quite that far. So just a sketch right here to say this is approximately negative 70. On the last slide, we saw the example of 810 degrees and saw that it looks the same as the angle of 90 degrees when drawn in center position because it shares the same initial and terminal sides. So we have a word for that, for angles that end up looking the same even though they have a different degree measure. That's coterminal angles. So another example of that, if you had the angle 30 degrees, so the initial side right here, and we open up basically a third of the way there to 90, so just a sketch of that. An angle that would look identical to that would be if we were to go around the circle one entire time and then go up 30 degrees more. So that branch, this terminal side, would be in the same place, but that actual degree measure would be 30 plus that one full circle that we did around. And again, remember, one full circle is 360 degrees. So really, we'd have 390 degrees being coterminal to 30 degrees. And we could repeat that process and go around another circle and just add 360 to 390 and find another coterminal angle. So there's an infinite amount of coterminal angles we could draw for any given angle. Alright, so finding that second coterminal angle, 25 minus 360 degrees, which would be negative 335 degrees. So that's going to be our first negative coterminal angle. So this example, we had answers of 25 degrees and negative 335 degrees. Alright, same idea for number 2. So we're going to need to subtract 360 to get to an angle that's smaller and closer to 0 degrees. This is the example we saw earlier, so we know we could subtract 360 degrees twice, which is the same thing as subtracting 720. So I'm going to go ahead and do that. And we get 90 degrees. So one coterminal angle would be 90 degrees. And then to keep going, to subtract and find another coterminal angle, 90 minus 360, which would be negative 270. So here's our positive and our negative coterminal angle. With negative 60, to get to a positive coterminal angle, we'll need to add 360. It's the same thing as 360 minus 60, which would just be 300 degrees. And then to get to another negative coterminal angle, we'll subtract 360. So negative 360 and negative 60, which would be negative 420 degrees. So our two answers are here.